Hello students, welcome to today's session of digital image processing. Today we will going to discuss in more detail about sampling and quantization. Okay, so to create a digital image we require to convert a continuous sense data into digital form. Okay, like if we have any signal in analog form. Okay, so we can digitize the coordinate value. Okay, and this process is called sampling, and if we digitize the amplitude value, this process is known as quantization. So we will discuss one by one in detail. So first is image sampling. So see, observe this sinusoidal wave. See this sinusoidal wave. It can be quantized. Okay, in different signals like this, shown in discrete form. Okay, so for getting this sampled value, we required one theorem called Shannon-Nyquist theorem. Okay, so according to that theorem, the sampling frequency should be greater than or equal to 2 into f max, where f max is the highest frequency present in the image. Okay, f max is the peak value of the image. Okay, now a continuous image, that is if it is represented in form of f of x comma y, it can be sampled into arrays. Okay, so like array is shown in the below, like a 1D is can be sampled into 2D image. Okay, which is represented by h of t. Okay, so for this we require one block called as digitizer. Okay, so digitizer, what it function it does, the sampling rate of digitizer determines the spatial resolution of digitized image. Okay, spatial resolution means what is the coordinate values of, that is x comma y. Okay, so the finer the sample, the better is the approximation of image function. Okay, so like if image is done more sampling, okay, so we can get more accurate image. Okay, so remember this. Observe this image, like here we have done sampling. Okay, like there are 1024 samples, so we are getting more visible image. Okay, if we reduce number of samples to 512, so the number of image clarity value, it is reduced. Okay, similar it is reduced, it is least for the sampling array value 32. Okay, so the more the number of samples, the more clear image we get. Now let's see what is image quantization. So the process of digitizing the amplitude values, it is nothing but quantization. Okay, see, quantum means parts or components. Okay, so number of quantization level should be high enough for human perception of fine details in image. See, our human eye means whatever the image we look, it is also means it is union of all such small parts. Okay, small quantums. Okay, so quantization level should be high always. The number of quantization level is given by k is equal to 2 to the power b. Okay, always remember where b is the number of bits, and there are 8 bits per pixel, means mostly in practice. Okay, so see this image, there are some sample points and quantization level. Okay, so 0 is the lowest level of quantization, and here it is 4 is the highest. Okay, now we have seen what is sampling and quantization. Now how we can generate a digital image using this both sampling and quantization. Okay, firstly we need to have one continuous image. See this this closed shape. Okay, dark closed shape, it is nothing but a continuous image. Okay, in the second figure we have done scaling. Okay, from A to B. See, this is A and this is line B. Okay, so this is scaling is according to the gray level. Okay, means it shows the darkness level. Okay, so in the third figure it is sampling. Okay, here it is sampling done, and in fourth figure quantization is made. Okay, So we can acquire digital image by using this sampling and quantization. Okay, now let's see how we can do it. Now the sampling means it is determined by sensor and element used to generate image. Okay, so the sensors can be a single or a strip of sensors. Okay, for means according to the customized requirement of the user. Okay, and quantization of the center output is completes the process of generating the digital image. Okay, so once we join all the quantized parts, okay, we get the digital image. So finally we can say that the quality of image, digital image, is determined by large degree by number of samples and discrete grade level it is used in sampling and quantization. Okay, so more the number of sample or number of quantization level is more, the more is the more clear image. Okay, observe this plot of gray levels and the pixel values. Okay, so the value is 255 for the most whitest part. Okay, remember, most whitest part. Okay, and the value reduces as we get the more darker image. Okay, so the most white part it is value 255, and the most dark, that is most black part, the value is 0. Okay, remember this. So we can get this digital image. Okay, digital image that is in form of 0 to 255 from the gray levels. Okay, this is how we can acquire the digital image. So students, this is last second block. Its value is 200. Okay, and 75 is value for this darker part. Okay, so for black it is 256, 255, and for white it is 0. Okay, remember this variation of gray levels and pixel values, intensity values. For black it is 0 and for white it is 255. So according to the number of quantization level, we can get more grayscale, more intense grayscale image. Okay, so like if we have one bit image, we can have only two colors. Okay, that is dark black and dark white. Okay, and as we increase the number of bits, we have more clear images. Okay, the 8 bit was the most clear image. Okay, now students, let's see types of sampling. Okay, so sampling, it has two types: up sampling and down sampling. Okay, so in down sampling we scale down the image by reducing half of the sampling rate. Okay, and in up sampling we scale up the image by replication or interpolation. Okay, we will understand this when we solve some sums based on it. Okay, so students, now let's see how to down sampling. Okay, downsampling is also known as subsampling. Okay, so now in this image we have how many pixel? It is a 4 by 4 pixel function. Okay, so how to do its downsampling? So it is 4 by 4, so we have to reduce it. Okay, we can after downsampling we can make it 2 by 2 pixel. Okay, pixel is a function of pixel size 2 by 2. Okay, so let's see how to perform it. So there are two different ways to perform this downsampling. Okay, so in first way what we will do, we will consider the upper left value of the matrix function. Here it is given as 3. Okay, so select that value of 3. Okay, and write it in the form of function of 2 by 2 matrix. Okay, so in this downsampled function all the elements of this image matrix will be the same, that is 3. Okay, So this method is nothing but single pixel selection. Okay, we call this as single pixel selection. Okay, so students, we have written this 3 by 3 3 3. Okay, and we call this method as single pixel selection method. Okay, in other method we can have average values. Okay, like we will consider any 2 by 2 matrix of this 4 by 4 matrix. Okay, like this top left corner, top right corner, top bottom right or bottom left. Okay, so if we consider this top left corner, okay, so top 2 by 2 matrix of top left corner, so what are the different elements? There are 3399. Okay, so here what we will do, we will take the average. Okay, means average of all these four values. Okay, find it out, do the calculation. 3 plus 3 plus 9 plus 9. Now let's see how to perform upsampling. Okay, so here have a matrix 2 1 1 3. Okay, 2 by 2 matrix, means there are two different ways. First is replication way and other is interpolation way. Okay, so in replication way we will do zero padding. Okay, so zero padding is nothing but you will take every element of this 2 by 2 matrix. Okay, top left element, here it is 2. Okay, so write this 2 element here and write all the zeros after 2. Okay, means neighboring values to 2 will be written as 0. In the next step we will do, as the word says, replication. Okay, so we will make the replication of all the elements, that is 2 is 2 is replicated as 2, like wherever it is 0, over there 2 will be written. Okay, so very easy. So in the first 2 by 2 matrix on the top left, it will be 2 2 and 2 2. On the top right it will be 1 1 and below 1 1. Okay, similarly the remaining bottom half of the this matrix, it will be also fulfilled. Okay students, this was the way to form upsampled function, okay, of 2 by 2 pixel size. Now let's see how to perform upsampling using the another method, that is interpolation. Okay, so we have 2 by 2 matrix. So how to do its interpolation? Okay, so interpolation we have to do in two steps. First is interpolation by row wise, and next interpolation by column wise. Okay. So students, here we have to follow the same step of zero padding. Like we will write 2, 1, 1, 3. Okay. In the means as we done in the previous slide, in the same positions, and we will surround those numbers with zeros on the three sides. Okay. So whatever the three sides are vacant, we will surround the numbers with zeros. Okay. And 1 0, then 3 0, zeros and zeros in the last row. Okay, so in interpolation what we will do, we will take average of first and third column. Okay, and write the average value in the below intermediate column. So wherever is zeros, you will write the average value inside it. So in the first and third row, first and third row, we have values 2010 and 1030. Okay, so add 2 and 1. What we have, we have sum of 2 and 1 as 3 and divide it by 2. Okay, taking its average, so divide it by 2. So we will write 1.5 in the middle. Okay, first column second row. Okay, so 1.5 will be written in the in between. Okay students, 2, 1.5, 1, then 1 means nothing is written on the right side of this 0. Okay, so we will consider it as 0. So 1 plus 0 is 1, divided by 2 it is 0.5. Okay, then again 0 0 zeros, because 0 plus 1 is 0, divided by 2 again it is 0. Then 1 plus 3 is 4. Okay, so we will write in third row as 1 2 3, and here we will write 1.5. Okay, because 3 plus 0 is 3, divided by 2 it is 1.5. Okay. Okay students, so in the fourth row what we will do, we will add it is as it is. Okay, so now we have done column row wise interpolation. Okay, now we will move on to column wise interpolation. Okay, so in column wise interpolation, this second and fourth row which is having total 0 numbers, it will be converted. Okay, it will be having numerical means real values. So interpolation row wise, column wise, sorry. So write the first row as it is, that is 2 1.5, then 1 0.5 we will be written as it is. Okay, so add this 2 plus 1, it will be 3, 3 divided by 2 it is 1.5. So in second row we will write 1.5 here. Okay, then 1.5 plus 2 it is 3.5. So 3.5 divided by 2. So add a 3.5, divide 3.5 with 2 and write its average value in the second column. It is 1.75. Okay. So 1 plus 3 is 4. Divide 4 by 2. You will get it as 2. So write 2 in the next cell. 0.5 plus 1.5. It is 2. 2 divided by 2 is 1. So 1 is written here. In the third row, we will write 1, 2, 3 and 1.5 as it is. Okay. So in the last row, we will add the alternate rows. So last row is containing totally zeros. Okay. But here it is 1. So 1 plus 0 is 1. Divided by 2 it is 1.5. 2 divided by 2 is 1, and 3 divided by 2 is 1.5. 1.5 divided by 2 it is 0.75. Okay, so students, finally we have got upsampled function. Okay, using interpolation function. Okay, so this is how we can calculate the upsampled function using interpolation factors, interpolation methods. Okay, so please comment if you have any doubt related to the process which is explained in today's session. Thank you.